This is the NEET 2021 question in electric potential and capacitance. The problem says two charged spherical conductors of radii R1 R2 are connected by a wire. So, let us have a talk about this part first. There are two spherical conductors. Say let this is having a radius R1, another spherical conductor having a radius R2. They are connected by a wire. So, what happens when they are connected by a wire is there will be a flow of charge from higher potential to lower potential until equilibrium is attained, right? Means, so what we can say, at equilibrium it will automatically get the equilibrium after some time, that need not be given. Potential of the first one equal to the potential of the second one. We do not know the charge on each of them. Let us assume charge is Q1 and Q2 on each of the spherical conductors. We know the formula for the potential as 1 by 4 pi epsilon naught Q1 by R1, charge on the potential on the first conductor, and the second one 1 by 4 pi epsilon naught, charge is Q2, radius is R2. So, from here we can rearrange the terms and write Q1 by Q2 equal to R1 by R2. That is one part of the problem. Then he want the ratio of surface charge densities. We shall know first of all what do you mean by surface charge density. Surface charge density is defined as charge on the surface per unit surface area. Unit surface area. So, being a spherical conductor, surface charge density of the first one will be, being a sphere, its surface area is 4 pi r square. So, second surface charge density is Q2 by 4 pi, this is R2 square, this is R1 square. So, if you want the ratio of this surface charge densities, then I shall write sigma 1 by sigma 2 is how much? That is Q1 by 4 pi epsilon naught R1 square divided by Q2 by 4 pi epsilon naught R2 square. So, if you rearrange the terms, Q1 by 4 pi epsilon naught R1 square, denominator of the denominator goes to the numerator, 4 pi epsilon naught R2 square by Q2. 4 pi epsilon naughts can be cancelled. So, this can be rewritten as Q1 by Q2 of R2 square by R1 square. But this Q1 and Q2 is not given for you in the problem, rather it was given that they are connected by a wire. When they are connected by a wire, in the place of Q1 by Q2, as we have proved, I can write R1 by R2. Then ratios of surface charge densities is, in the place of Q1 by Q2, let us write R1 by R2. What is remaining is R2 square by R1 square. So, one R1, one R2 will cancel. So, what is remaining is R2 by R1. So, ratio of surface charge densities is R2 by R1. That is how we have to solve that problem. That is it. It is a simple problem. Thank you for watching.